All right, good afternoon, everybody, and welcome to our PHP Performance Principles and Tools webinar. What we'll be talking about today is some of the principles and tools that you can use for building performance into your application and making your application more responsive. So we're going to cover a fair number of topics here, and so we'll probably just get right into it. The first thing to talk about is, I guess, myself. My name is Kevin Schrader. I'm a technology evangelist for Zend. I'm relatively new to the position, but I've actually been with the company already for several years. And I've had the opportunity previously to this position working in the Global Services Department, which basically means that I get to work with an awful lot of different customers. So it's a new position for me, but it's something I'm actually very excited about doing, getting to talk about a lot of the different products that we have and how they fit in with hopefully real-world solutions, and that's really what we're going to be talking about here today. A programmer in C, not too much C, a couple of other things, and I've also worked as a system administrator on the Solaris systems, Linux systems, and I've also done a little bit of Windows stuff as well, though my own experience has been more on the Unix side of things. I'm also an author. The first book that I wrote was, co-author on, was IBMI Programmer's Guide to PHP. That's the one that you see there. If you're one of the IBM folks on the phone, welcome here. Definitely aware of some of the things that you need to work with when you're dealing with performance. So there's that, and there's also a second book, which is going to be coming out later on this year, called "You Want to Do What with PHP?" It's brand new. It's kind of about things that PHP developers don't often look at in terms of features that they have or techniques that they use. So that's coming out a little bit later on this year, and I'm really looking forward to that. And you can see my my thing I do on the weekends there. Somewhat true, somewhat not true. I'll let you decide how much that is. For the webinar today, we're going to be doing something a little bit different. We're going to be trying something out new that we haven't always worked on or haven't always done with some of the webinars we've done. First of all, if you have a question, that's going to be done one of two ways. You can actually type in a question in the Q&A panel on your webinar control panel. There's a question mark that you can click on and enter in a question, or you can also type into the chat as well. The thing that we're doing new this time is actually we're going to be using Twitter for doing some of that as well. So if you have a question that you want to have answered in this webinar, or even at some point past this webinar, feel free to tweet it, giving you the tag there that we're going to be watching for. I've got it up on another monitor here, so if you do have questions, you can put them there. I can't guarantee that I'll get to all your questions. My understanding is that this is actually there's actually a lot of people who are registered for this webinar, which may mean a lot of questions. May not. We'll find out. But we'll be monitoring Twitter for that tag, and we'll see how it works. Please be gentle, though. It is a public forum, so if you do have any questions or criticisms, do present them in a civilized manner. We also have a couple of other things here. If you want to follow us on Facebook, I have a link there that you can type in. I tried typing in the full link for Facebook, but it was rather long, so I just put it in the bit.ly there, and so you can do that. Or if you're just on Facebook, you can just do a search for Zend. I'm actually the one who manages the Zend Technologies page on Facebook. So if you see any comments there, it's most likely going to be me that's making them. No, not always going to be the case. You can follow us on Twitter as well at Zend, and you can also follow me at KP Schrade. That's on Twitter as well. If you have any questions or just want to find out what's going on with Zend or PHP or anything like that, you can follow me there or follow Zend on Twitter there, or become a fan of us on Facebook. Either way, we are happy to hear from you and happy to have you following us. So what we're going to be looking at today are a couple of things. We're going to be looking at the database. We're going to be looking at network latency, I/O contention, CPU utilization, network connectivity, and then also a fair amount of time we're going to be spending with best practices or pitfalls or things like that. We're not going to be going and having lots of examples or something like that. We're going to be trying to stay with the more of the principles that you need to follow. And the reason being is that when you have only an hour's worth of time, it's difficult to really get good examples that people can learn from. So we're going to talk about principles here. Because of that, they may not be necessarily as practical as if we had a direct example, but at the same time, you can take that, the examples that we look at, and you can learn from them and apply for them, or just give you a different way of thinking of things, perhaps. So the first one we're going to be looking at is going to be looking at the database in terms of some of the performance aspects that you have. In terms of the tools, there's primarily two ways that we can look at performance in the database. The database is actually going to be one of those places that is going to be pretty high on the list when you're looking for performance issues in your application. There's always an ongoing question as to whether or not you need to be worrying about performance or scalability, and that performance is not scalability, scalability is not performance. And while that's true, there definitely is a benefit to having an application that is both scalable and performs very well. You've obviously seen a lot of the information going back and forth about hip-hop, the implementation of PHP that Facebook has. Technically, that application is all about performance. It has nothing to do with scalability, simply because what they're trying to do is they're trying to reduce their CPU usage so they can scale higher, so they can do more vertical scaling. And so when we're talking about the difference between scalability and performance, the two are actually related. Your ability to scale horizontally can be related to your horizontal architecture that you have built out. And so while the two technically are different, they are related. And so when we're looking at this here, particularly when we're talking about performance here, performance does impact the scalability of your application. And so when we're looking at the database in particular, there's a couple of tools that we have. One of them is to use Zen Server. There's a set of monitoring tools, which we're going to take a little bit of a look at later on. Obviously, this is a talk that's more about performance than about tooling, but at the same time, you can't have a talk about how do you diagnose performance problems without having some discussion on tooling. So we'll try to minimize some of that, but it wouldn't be a complete presentation without doing that. The other one is to use some kind of inter-application query monitoring, and this is usually going to be done via some kind of a database abstraction layer. ZenDB in the Zen framework has the profiler, the database profiler, which you can use to get performance timings. Another thing that I don't have in here as well is a slow query log that you can see from MySQL. MySQL is they have the slow query log that you can look at, that you can determine, set some kind of a threshold that will then log queries that are taking longer than they should be, or than you would want them to do. So when you're looking at database types of performance issues, there's a couple of symptoms. The primary symptom is that you have long page load times. That you have Apache or IIS or PHP using proportionally less CPU time. And that's simply done using some kind of operating system tools. A lot of you, if you're on the Linux side, are going to be familiar with TOP. Another one is VMstat, though VMstat is more system-wide as opposed to process-wide. So TOP is usually a good idea. The System Internals Process Explorer, which I have up right now, is a great tool whenever I do work on Windows. Actually, pretty much every Windows machine I have, including the ones that have nothing to do with the server whatsoever, I have this installed on, and you can see your PHP side. So using this type of a tool to simply monitor your the performance on an individual server does give you the ability to kind of diagnose where those issues are occurring. Database performance issues are often one of the easier ones to diagnose, simply because you have your web server and you have your database server, and if the database server is the one that's acting up, you know that that's your problem. Of course, it can be related to your application and the way you're doing things, but it's relatively easy to diagnose. In terms of the remedies for dealing with performance in the database system, there's actually two primary ones, and they are both the exact opposite. The first one could be to simplify our queries. Knowing your database is really a big part of building out your application. some databases do certain things better than others, and it's really a good idea for you to know that. For example, I've ran into a situation, it was a little while ago, so this may have been improved, but there was a query being done against a MySQL database that had basically 3 union calls in there. And what ended up happening was this one query would end up taking 35 seconds to run. It was a gorgeous query. I mean, if queries can be gorgeous, it really showed, a lot of thought, and the guy who wrote it was obviously very, very smart. But the problem with it was that it didn't use the database in a way that actually, the way the database wanted to be used. And so what we ended up doing was basically taking that union, splitting it up into 3 queries that were each simpler than the other one, and we went from 35 seconds down to 3.5 seconds immediately. And so simplifying your queries is definitely one thing. Another thing could be simply to make your queries more complex. In other words, putting in more either more conditions or developing some kind of a join or something like that, work off of a primary key a little bit better rather than doing a table scan, using something to make your query a little bit more accurate, and use the functionality of the database a little bit better. And so these are 2 different ways that you can look at actually improving the performance of your database simply from the query side, so actually changing some of the logic in your application. And then the last one is to tune your database. That's a question that I'll leave to database administrators. Often developers are not the best people to have around for doing that type of tuning because it requires a very specific and very specialized level of knowledge. And so tuning the database is good if you know how to do it. But if you don't know how to do it, it's not a bad idea to just admit that you don't know how to do it and get somebody else either to come in and do some kind of an analysis on your database. The next one that we're going to be looking at here is network latency. Network latency is probably going to be one of the more difficult ones to diagnose. And the reason being is that it doesn't have the same types of symptoms that we see with something like a database. The database, it's very clear. You have high CPU usage on your database system, and clearly it's your database. If you're having CPU contention on your or high context switches on your web servers, then it may be your application or your web server just being overutilized. When you're dealing with network latency, because it's internal to the application, or typically internal to the application, it's sometimes difficult to detect when that's actually occurring. A couple of the tools that you do have to determine whether or not you're having a performance issue that's related to network latency is XenServer. XenServer has some mechanisms for monitoring slow function calls, and so you can do that to see when you have a slow fopen or a slow socket connect or something like that. You can use that to see what's actually going on in your system in a way that you might not be able to get through normal channels. And then you have 2 other ones that are actually very useful, Wireshark and TCP dump. If you're not familiar with those 2, I would highly recommend getting to know them. Both of them work on the Linux system. Wireshark has an interface for the Windows system. I have Wireshark installed on, again, pretty much all of my systems. And it gives you a level of detail about what's going on on your network that's really quite useful. One of the benefits to that is that you can watch the individual packets going across the network, and you can get the timestamp that each one of them was sent, and you can actually use that to determine what the elapsed time is for doing something like a connection or something like that. So some of the symptoms that you can see here when you're working with network latency is that you have slow page responses but low CPU usage. Actually, that's something that's quite often when you're dealing with networking issues, is actually low CPU usage with slow page responses. I did see that, I think it was earlier, not this year, but last year, where a customer was having issues where their website would just all of a sudden just halt. It would just stop for no apparent reason, and then 10 minutes later would just start going. And the reason was because of a networking issue. I won't get into the details as to what that networking issue was, but if you have some kind of unexplained increased page response times with low CPU usage, then network latency or networking issues can actually be a strong possibility for the type of issues that you're seeing. Some causes that you might see are things like network saturation, though in these days of gigabit Ethernet, gigabit networking, that's somewhat unusual, though it has happened before. DNS reverse lookups are another issue that can be something that can cause that, and that doesn't really make your application really any slower. It's just it's got some more time, then it's got to wait for data to come from some other kind of a source. And so using IP addresses, and if you have to know the server name or the host name of the machine that's calling your server, store the IP address and then batch it later on. That's a much better option rather than running it, rather than doing that at runtime. TCP handshakes can actually be another issue. If you're not familiar, we'll see this in a slide coming up, but the TCP handshake is actually a three-packet procedure that needs to be done in order to make your application or make a connection go into its open state. And if you're running into issues, particularly when you have to make consistent connections over long distances with multiple hops in between, you can actually see a pretty significant increase in your response time based off of that. I remember reading something, it was a while ago, and one guy did a calculation, and I don't know how accurate this calculation is, so take it with a little bit of a grain of salt. But what he was saying was that once you factor in the best response time of all the routers, factored in with the response time of the speed of light going over fiber, you were looking at several milliseconds of delay for any kind of communication that's going across the continental U.S. Actually, a relatively significant amount of delay going across the continental U.S. And so if you're opening a connection on a remote server that's on the other side of the continent or across an ocean, you can have a significant impact on the performance of your application. Using some kind of persistent connection can sometimes help with that, but you still do have that handshake that needs to be done. Persistent connections will actually probably benefit you a little bit there because TCP has the ability to be pipelined. So what it'll do is it'll send out a whole bunch of packets and not wait for the next response, but I don't believe that TCP will do that with a connection. So the connection is a synchronous operation, whereas the data transfer can be to some degree asynchronous. That's a gross simplification of how it works, but that's something that is a possibility. So here we see an example of why that is. You have basically your SYN. That's the first packet that goes out to the server, so your client does a SYN. Then you have a response back from the server, and that's the ACK, and then you have your SYN-ACK that is sent back, and at that point you can start sending data. But not before then. There was, I think I remember something that saying that IIS a couple of years ago would sometimes be able to figure out whether or not IE was connecting to it and would actually send data prior to at the SYN or after the SYN. I don't know how true that was. That was a little while ago, and I don't know if that's still the case, if it is true. There's an actual tangible benefit to doing that because TCP does have a three-stage handshake process. So that's something to at least be aware of if you're making some kind of remote connectivity. And here's why. When we're talking about individual hops or going through your going through various networks to get to your data, you have when you're looking at this from your I forgot the name of the standard that this is, but you basically have your server goes down to through your various layers, goes into your switch or your router on one network, which then reads the physical layer, gets the Ethernet layer, and then reads the IP address, figures out where it needs to route it, and then this here goes over and over and over again until you actually get to your destination, at which point you get to it has its own physical layer and it eventually bubbles up to the client. Every single packet is doing this that you send out to or that you have to do to communicate between the client and the server. And so minimizing that, minimizing the number of packets is something that can definitely be beneficial if you're dealing with data that's being transferred over long distances. The next one that we're going to be looking at here is I/O contention. This is pretty unusual to run into, but it does happen. One of the things that you can do, again, is because of the monitoring tools in Zen Server, you can watch for long fopen calls. You can also look at vmstat and top on Linux. vmstat and top will give you a second by second, if you state that you want a second by second, but you can see your user time. You can see your system time being as a percentage of available resources, and you can also see your I/O wait time. That I/O wait time can be relatively important. There's a couple of symptoms of this. The primary one that I've run into is that you have unpredictable and difficult to reproduce page load times, and what they tend to be is that you have your data kind of going along, and your response time is okay, but then your response time starts to increase, but then all of a sudden your response time just tanks. And that's often can be an indicator of high I/O, because at some point you just hit the physical limit of the hardware and it just drops. Whereas CPU, because of the way your CPU and your OS switches between the various processes that are running, you may have a more gradual curve that you're following along. The I/O contention has a tendency, not all the time, but often has a tendency to increase and then just absolutely tank at some point. There's a couple of causes that can cause this. One of them can be that you just simply have too few spindles or just insufficient hardware serving too much data. If you want to increase your performance, you can simply add some kind of a couple of additional disks onto a machine. Disks are cheap, and then use some kind of a hashing mechanism or something like that to distribute your reads and your writes across the individual platters. Another one can be high write concurrency. Writes are actually a very expensive operation, particularly because you want to be sure that when you actually write data to the file system that it's actually been there. So writing tends to be a synchronous operation. There are options that you can set on your file systems to do asynchronous writes or buffered writes, or in some cases you can have them write to the journal and then immediately return, and then let the file system actually do the write later on. But writing has a tendency to require some kind of confirmation that the data has actually been written to the disk. And another issue or another cause can actually be insufficient free system RAM. You've probably heard that one of the best ways to increase performance on a system is to basically add more RAM. And one of the reasons for that is because I/O, or particularly disk I/O, is much slower than RAM access. And what the operating system will do, because RAM is faster, it will take the disk pages that you have on your physical disk, and it'll try and store them in RAM. And if you have a read-heavy application, that actually means that you can have your operating system do a lot of caching for you, and you don't have to make any changes to your application because it's system level. And if you don't have enough free RAM, then the system may have to actually move the drive heads in order to retrieve that RAM or retrieve that data. If that data is stored in RAM, the drive heads don't need to be moved. You don't have your wait time trying to get the disk to the right position. So by having that cached in there in RAM, you can make your application run much quicker in some cases, particularly when you're running into things like I/O contention. I see that there's a question on monitoring. That's a question I'll actually wait until the end to answer, but I'll keep that there. The next one we're going to be looking at is CPU utilization. The easiest way to do that is, again, just simply using top and using the System Internals Process Explorer on Windows. Those two are the primary ways you can see whether or not you're using excess CPU. The symptoms are actually relatively easy to diagnose. Basically, your page load times either correspond directly to CPU utilization. Well, not necessarily CPU utilization, but the run queue. The run queue is something that you actually can see that in VMstat, which I don't have down here. I had mentioned it earlier, but VMstat is another way that you can do. You can look at that. The run queue is the number of processes that are waiting for CPU time. And what I've found, and this is a very, very general principle, but what I've found is that once you get your run queue to being the number of CPUs on the machine minus 1, so if you have an 8-core machine that you have a run queue of 7, that kind of tends to be the threshold of when your performance really starts to drop off, which makes complete sense why that would be. It's not a perfect comparison, but if you see a high run queue, and that's if you're looking at VMstat, it's going to be all the way on the far left-hand side of that report. You can see whether or not you have a lot of processes that are waiting for time. Your load average is to some degree calculated off of this, though that is definitely not the only thing that's taken into consideration. And the load average can change from system to system. Linux systems, a load average of 3 is still, it's a little high, but it's not really that big of a problem. I saw on a Solaris system once that had a load average of 350, and it was still performing fine. It was overloaded, and it was just about there just about ready to tip over, but it had a load average of 350, and it was still doing. The causes of CPU utilization, some of them can be your fault. Some of them can just be the nature of your application usage. But one of them can be bad code or over-architected solutions. I've actually run into situations with infinite loops that can basically are a cause of that. That one's a pretty easy one to see. Basically, you have one request and your CPU runs off to 100%. That's usually relatively easy to find an infinite loop, and thankfully, infinite loops tend to be relatively unusual in the web programming world. I don't run into them that often. If I do, it's usually actually because of a C-based issue as opposed to a PHP-based issue. One of the ones, though, that I've run into more often is excessive recursion, and that's basically when you have your application calling itself, and then calling another part of it, and then calling another part of it. And what I'm talking about here is actually like an architected recursion, one that's actually by design. All that recursion has a tendency to increase the amount of processing that's needed to do, because recursion has a tendency to breed more recursion. And so you've got to get through all those levels of recursion before you actually have before your functionality is actually done implementing, and because of all that, you have increased CPU utilization. So that's something to at least be aware of when you're architecting your solutions, that recursion can actually impact that pretty significantly. Another one that you might be a little bit surprised to see here is excessive I/O. And if you're the reason why you'd be a little surprised to see is because CPU and I/O are two completely different things. However, if you go back to our previous slide here, you see this insufficient free system RAM as being something that solves your I/O contention issues. Well, what can actually happen is, even if you have a system that has tons of free RAM, if you see a high system time in your VMstat or in your top, what that can actually be an indication of is that your application is doing too many operations on the file system, but because that data is being cached in RAM, it's not showing up in your I/O wait time. So if you see excessive, or if you see high system time on your, particularly on a Linux system, that can actually be an indication of there being too many I/O operations in your application. And so, being aware of that and looking into your application and seeing where you're spending your time and how much disk access is actually going on there would be one of the things you want to do to further diagnose that. But excessive I/O can be a cause of excessive CPU utilization. And then the last one is basically a no-brainer, just that you have too few servers serving too much traffic, and that you need to be able to scale out your system a little bit more. And so I talked about this a little bit earlier on. There's basically two different paths that you can follow in terms of the CPU utilization. The first one is user time. This time being spent executing the code that you want, and then you have system time, which is time spent running functionality that your code calls, such as your network or file system or things like that. It's all kind of a big web, everything's interconnected, but those are the two different paths you can route. Typically what you want to do in your application, or what you want to see in your application, is actually high user time. Because the more time that's being spent running in user time, that's time spent running your PHP code. And so if you have maybe, and this is just a random number, well, not a random number, but kind of off-the-cuff number, but if you have a ratio of 8 or 9 to 1, then you're usually doing pretty good in terms of what your CPU utilization is when you're splitting between your user and your system time. Again, not a hard and fast rule, but if you have an 8 or 9 to 1 ratio between user and system time, that you have that you have 8 times more user time than system time, that's usually a pretty good indication that you're doing all right. Network connectivity is actually a little bit different from network latency. This is it's definitely related, and some of the symptoms can be, have database or web service calls taking too long. And another one that is going to be more indicative of this, because we've already talked a little bit about network latency, but if read functions die unexpectedly, if we so you either do an fopen to using the stream handler, could be to a website like an HTTP website, or you could do an SSH using the SSH stream. But if you have some kind of a read function that dies unexpectedly, that can be an indication of that type of an issue, and you can get that again by watching the monitoring for the socket connect, fsocket open or fread or something like that. And again, just like with the network latency, the Wireshark and TCP dump are actually good tools to use on there. Particularly for doing, if you're trying to make a connection, you can actually, and you're having a failed connection request, using something like that, you can go in there and it'll show you the SYN ACK, and the ACK packets being sent back and forth, and you can see which ones are failing. I use Wireshark and TCP dump more than perhaps I should, because it really does give you that kind of information, a lot of really good information. So another thing you need to be aware of is the nature of the architecture that you're going to be working with. One of the things that I have run into on more than one occasion is when people are working with large collections of data, they often need to be, they're not as aware of the impact of the relational mapping techniques that they're using, or the data access methods. Active Record is something that has come up in the past couple of years as being a great way to speed up your development time, where you basically have a one-to-one mapping between your object, your model object, and your database or a table row. Even though there are definitely benefits to it, there also can be drawbacks to that. And this example that we have is just some timings that I've done. I did it probably about 2 years ago, but I believe the numbers they would still be quite pertinent. And I did basically 2 mechanisms of loading up the data. The first one is using the active record, basically one database call for one row for one object, and then using a collection approach where I basically did a where clause and populated an object based off of the full result set, instead of doing a single call on the primary key. And this was the differences that I saw between the two. When we had a limit of 100 individual objects, the active record mechanism came back about 5/6/1000ths of a second, which really isn't all that bad, but the collection came back in 2 1,000ths, or that is 6 100ths, as opposed to 2 1,000ths. You see, do a limit of 500. Came back quarter second, still not that bad, but when you compare it to the collection mechanism, which came back in 8 1,000ths, you have a limit of 1,000, and active record came back in 5 seconds, as opposed to the collection mechanism, which came back 1 100th. And then we see what happened when we did unlimited, which had 250,000 rows, which came back in 13 seconds using the active record, and then 0.2 seconds in the collection mechanism. Now, this isn't saying that you shouldn't be using active record. Far from it. What this is saying, though, is be aware of your data access mechanisms, because these numbers were generated on a very bored system. There was no kind of concurrency, there was no locking, there was nothing else, and there was still a massive difference between the two. If you're only dealing with 5 or 10 objects in an individual request, by all means use active record. If you're using 1,000, start being careful. If you're using many more than that, definitely beware of it. And the reason I bring that up is because I did run into a situation where a customer was using an active record implementation, and they were loading up 25,000 objects for an individual request, and they had good reason to do it. But the implementation, the effects of the implementation they had not been calculated earlier on, because they were following just simply the active record mechanism, saying, well, that's the way we're going to do it. And it's something that's going to be that you need to be aware of currently too. The cloud is something that's that's up and coming. It's making a lot of waves right now. One of the things about the cloud is that it is you're not dealing with the same level of structured data in many cases. In some cases you are. This is again one of those blanket statements that doesn't pertain to everybody. But be aware of your data access methods is really what I'm saying here. Use the cloud by all means, but be aware of the unintended consequences of using that. There was an entry that I think it was on the high scalability blog, which if you don't go to it, it's a fascinating blog to go to. And I think it was on this blog where they were saying, when you're talking about the cloud, you're not going to be dealing with high-end hardware. What you're talking about is lots and lots of commodity hardware, and that's something that you need to take into consideration. If you're used to building on a mainframe, or you're used to building on a 32-way system with local hard drives, the way you're going to program is going to need to be different when you start working in the cloud, because it's a completely different set of hardware, a completely different set of principles that you need to take into account. So from the PHP side, this is a slide that's gotten me into a little bit of trouble. Well, not too much trouble, but a little bit of trouble. Is to be aware of the magic methods, specifically get, set, call, those kinds of things. I am not saying do not use them. I use them all the time myself. Zen Framework uses them. There are places where the magic methods are beneficial. However, when you start dealing with a modern-day application and we start talking about that whole recursion and calling itself, or the application calling itself, then calling itself, then calling itself, this kind of stuff can actually happen an awful lot. I did one type of a benchmark, again with another customer situation. They actually had a very minor number of actual database calls. They're using, again, some kind of ORM, doing a very minor number of database calls, but because of all the subsequent processing that was being done on there, they were calling their get and their set mechanisms 650,000 times for an individual request. So that's a situation where they either need to take a look at the architecture that they're doing, statically define individual properties or methods that are going to be used, but those were things that can have that unintended consequence, and that's what can happen when you're dealing with magic methods or ORM, or not being familiar with the operating system that you're using. The unintended consequences can actually be rather large, and so the magic methods, one of those things is where the unintended consequences can be large if they're not used fully or used sparingly. They're often also used when you're using some kind of an object that has no knowledge of any kind of underlying functionality. So some examples of this could be SOAP requests or COM objects, Java objects, or even database tables if you're using database abstraction. Just be aware that if you have a complex data model and you're using get, set, and call an awful lot, that when your data set starts to expand, you could see some significant impacts on the performance of your application, and also because of that, limiting the overall scalability of your application. Be a little bit aware of regular expressions. Regular expressions are by no means evil. Their syntax is, but regular expressions are something that is very useful when you're doing some kind of data checking against complex data. However, if you're not using complex data, it's probably a good idea to not use regular expressions. Some examples that we have here is checking whether or not a data dollar website here contains a URL. This stir IPOS compared with this preg match is the stir IPOS is twice as fast. In this one, if we're checking to see whether or not a string has alphanumeric characters, C-type alnum is almost 5 times as fast as preg match. And one of the things that is not done as often as it should be in PHP programming circles is casting to specific data types. PHP has the reputation, to some degree, of being a typeless language. That is not correct. PHP is a dynamically typed language. In other words, you can change the type of a variable very easily based off of PHP's internal type juggling rules. So if you're going to be doing some kind of testing, in this case, testing to see whether or not a digit, so an individual number, is in the data, we here just simply cast our data to an integer and see whether or not, when we apply our type juggling rules, whether or not they match. In this case, just like C-type alpha, it's 5 times as fast, and so that's something to be aware of. Now, I have a slide coming up a little bit later on talking about micro-optimizations and how pointless that is. But again, when we're talking about things where you have a lot of recursion and a lot of things that are kind of happening automatically for you, this can impact you. Hopefully not too much, but it definitely can. Code acceleration. If you are not using code acceleration, you really need to be doing it. The way PHP works out of the box is a request comes in, PHP checks for that file, it loads that file, it compiles that file, it executes that file, loading up any subsequent files that needed to be loaded and executed as well, runs the entire request. At the end of the request, clears the memory and starts over from scratch for the next one. What an opcode cache, or what code acceleration does, is it basically takes those opcodes, and the opcodes you can kind of think of as your binary code or your byte code that is the internal representation of the data or of the application that you have. It'll take that data, which is basically just a big array, and it'll throw that into shared memory. Then the next time a request comes in, that PHP or the code acceleration extension, whichever one you're using, will check shared memory, see if it has those opcodes stored in there. If it does, it'll just simply take those and it'll completely bypass the page load and the compilation stage. This is a test that I had here that I did on WordPress. Again, this is an old one, and actually this is out of date. I think it's actually done using the Zen platform code acceleration. And the new Zen Server Optimizer Plus is a fair amount faster than the one in platform. But even so, regardless of that question, we see here a 4-fold increase in performance, and the way we basically did it was by flipping a switch. This requires no changes to your code, and you basically turn it on and it works. Zen Server CE has Optimizer Plus built into it. Zen Server CE is free. You can download it from the website. You get code acceleration right out of the box with it. There are also several open source alternatives that you have. I shouldn't say alternatives, but open source options. APC is a big one, eAccelerator. These are all things that because you really don't have to pay for code acceleration, there's no reason not to have some kind of code acceleration installed on your server. The question here, do you queue? One of the things that has not really taken hold yet in the PHP development community is the notion of queuing or offloading tasks for later execution. Not to say that it's not done. There's actually several different options that you have out there, but it's not a bit of functionality that a lot of PHP developers end up actually using an awful lot. What it basically does is, if you have some kind of a long-running request, and an example of this could be doing a credit card transaction. If you have a long-running request and it ends up tying up your front-end server, what you can do is you can shove that off to some kind of a back-end server, because front-end servers, particularly if you're using some kind of a pre-fork Apache or something like that, there's a very distinct limit on the number of concurrent connections you can actually have coming in. And the last thing you really want to do is have your front-end web servers in a wait state, waiting for some kind of data from a third party. And so what you can do, if you have any kind of lag or any kind of a long-running request, say you have a report that needs to be generated, the same principle applies. What you do is you take that functionality and you offload it, send it off to a back-end server somewhere, and you process it. You process that long-running request as you have available resources to do it. And then that allows you to finish up the request on the front-end side, close the connection, and then come in and let another connection come in and actually handle the request coming in. So you get a significant benefit not only in performance but also scalability as well, because what you're doing is you're allowing data to come in and you process it as you have the ability to do, but it doesn't affect your front-end users on the same level as if you were doing that processing on your front-end web server. It's something that's, like I said, hasn't really taken hold very much in the PHP development community yet, but it is increasing. And I think that as we see PHP deployed on more and more and more web servers, larger sites, and having more enterprise-level people implementing and deploying PHP on their internal infrastructure, that this is going to become more and more important. There's two different types of queues that you can end up using. The first one is a job queue. This is for if you're doing something like processing a credit card transaction or building out some kind of a report. You want to shove this off to a back-end server somewhere else and have it handle that functionality. The two examples that I have here are Zen Platform or Zen Server 5. 5 is currently in beta. It's not available yet. And another one here is Gearman, which does a similar thing, but it has a different architecture, things like that. Then the other one is message queues. This is when you don't necessarily have processing that needs to occur asynchronously, but when you have data that needs to be transferred asynchronously. And so some examples that we have here are ActiveMQ or RabbitMQ. For my ZenCon presentation on integrating Java and PHP, I had an example using ActiveMQ, being able to send messages back and forth between individual machines. Again, it's not something that's done an awful lot in the PHP world, but it's something that rather than doing the whole polling of a web server, are you done yet, are you done yet, do you have data for me, just open up a connection and wait until the person who's processing that data is actually going to be sending it off to you. It means you're going to have more TCP connections connected to your messaging server, but at the same time, those TCP connections are just going to be sitting in a wait state. They're just going to be sitting there waiting for data to be coming in. So it's not actually going to be costing you as much CPU time as if you were actually having your end users pulling the web server trying to get that data back. So a couple of things, we're kind of approaching the end of our time here. We've got about 10 minutes or so, but we've got a couple of things to talk about here. A couple of things not to do. And this is by no means a complete list. There are lots of things that you should not do. The first one is to say, oh, we'll just cache it. If you're going to take that approach, you still have the original issue that you had. It's just masked. And that means that as you scale out a little bit higher, when your cache expires, you're going to be taking a bigger and bigger hit. That's not to say caching is bad. In fact, caching is something that I would recommend to do on almost any public-facing website. But caching should be the last thing that you're going to be looking at in terms of improving your performance. You'll get a big bang out of it. You'll have a big change in the impact of your application, but it should be the last thing you do. Build your application with caching in mind, but don't just say, oh, we'll just cache it, because that one time when you have that perfect storm of time to lives that expire at the exact same second will be that one time when you're about to be featured on Oprah or something like that. Be aware of try and make your application as efficient as possible, and then once you figure you've got most of that stuff out of the way, then you'll worry about caching it. Next one is saying that your NFS server is just fine for serving PHP files. I hate to break it to you, but no, it's not. It's one of those things. I did it was a recent one that I looked at, and the customer had I think 5 servers running off of NFS, and we put them all locally, and there was a 4-fold improvement in performance just by doing that. I could get into the reasons why that is, but basically what it comes down to is you cannot cache. You cannot assume that the cache for your NFS on your local machine is accurate. NFS, I think, as the most recent version, does allow for client-side caching, but it still has to check back with the NFS server to see whether or not that disk page is still valid. And so there is still, even though it's better than it used to be, it still takes a pretty significant a significant hit over a local disk. So deploy to a local disk if at all possible. The next one is to say, well, that like query is actually necessary. It might be, though I would really doubt it. In many cases, you can structure your data differently to remove a like query. And the reason why like queries are bad is because they're very hard to optimize. They're very hard for the query planner to optimize, very hard to build an index around it. If you have something like that, you will either need to build your structure a little bit different to make your data more distinct, or you might need to use a search engine instead. A search engine will be able to do those kinds of fuzzy searches a lot better. You have ZenSearch Lucene, which is one option. Then you also have something like Solr. Solr is basically a server implementation of the Apache Lucene software. I know of a lot of large customers who are actually using Solr and using the RESTful web services to do their searching on that. You have the issue where you might have your data a little bit out of date compared with what you have in your database, but if it keeps you from having to do a like query, that may not be that big of a deal. And here's the one I was talking about micro-optimization. You may have heard that arrays are faster than objects, so you'll just use them instead. Or using one function call over another, or structuring your code in a certain way. Don't worry about that stuff. The worst one that I've seen here with arrays being faster than objects, I think I saw a 4% difference, specifically calling data in an object as opposed to data in an array. That 4% is relatively minimal because you shouldn't be, I shouldn't say you shouldn't, but you will often not be spending that much time accessing data. Most of the time you'll be spending in actually processing that data. And so that 4% dwindles very, very quickly. So basically what I'm saying here is beware of micro-optimizations. Then the other one I've heard, and this one is actually a relatively common objection, is that monitoring and diagnostic tools are too expensive. If you are running an application that touches customer data, touches production data, has anything important to your business whatsoever, monitoring and diagnostic tools are not too expensive. Not only they're not too expensive, they're virtually required. We have some. There are open source tools that are available. There are other for-pay tools that are available. Monitoring and diagnostic tools are a necessity. So, looking at going from what not to do to going what to do, again saying this is not complete. This is one of the few micro-optimization things that I'll actually agree with doing, and that is to minimize your require once calls. Require once is actually a fairly expensive operation, so use an autoloader if at all possible. That can have, and actually it can have a pretty significant impact on your performance. PHP likes to have horizontal architectures rather than vertical. In other words, PHP applications tend to perform better when you have a wide layout of classes and inheritance rather than having a deep level of inheritance and classes in your application. People from Java backgrounds tend to think more vertically. PHP likes to think more horizontally because that's more efficient from the PHP side. Doesn't mean you can always do that, but if you can, be aware of that. Also, use lazy loading or load on demand. That can definitely drive or have a significant difference in your application. There's another situation I ran into where they were the customer was loading up 140 or so individual objects that they ended up using only one, but they didn't know which one they needed to use. And so what I ended up doing was using the array iterator, I think it was the array, or the iterator interface, and I used a lazy loading mechanism, or loading on demand, and this had a marked difference. We're talking 2 orders of magnitude difference as opposed to loading it all up front. So if you can load things lazily, that is definitely great. And I think that this is my last one, almost. Think before you code. Think about what you're going to be doing. Your best tool isn't an IDE. Your best tool isn't some kind of a server product out there. Your best tool is your brain. Use your brain. Use your mind. Use those tools so that you can tell your brain what it needs to look for. But thinking is primarily going to be the thing that helps you the best, rather than having to dig through pages and pages of diagnostic information. If you think through what the impact of what you're going to be doing is ahead of time, it might save you from having to doing that to begin with. And then also use diagnostic tools. Obviously, I love to play ours up primarily because I really do think they're good. When I was working with services, one of the first things that I would do is I would install the Zen Server Monitoring or Zen platform. And when Zen Server came out, the Zen Server 5 beta came out with code tracing, that was the first thing that I installed in there too. It just gives you so much information. The next one is using some kind of a profiler. I did a quick calculation. This is Kevin's calculation, so it may be wildly off. But what I basically found was if Zen Studio makes you 0.5% more productive over the course of a year, it's basically paid for itself. And we're using something like a profiler. And I'll just give you a really quick example of that. You basically have something like this with your toolbar. You click on Profile, and you get to see where your application is actually spending it. You can go through that and see where it's going. Another thing is code tracing. Code tracing is very similar to profiling. This is another one of the diagnostic tools that we're talking about, and I would love to give you some more information on Zen Server. We do have more on our website, and we've also had several webinars. But code tracing is designed to run in a production environment, do very much the same thing. If I go on there, I click trace, I get a trace. This brings up an Adobe Flex application that we built that allows you to actually look at your production data. This is what had come up from that request. I can highlight the most consumed path. I can go into there. I can click on this, and I can see the return values. I can see the percentage of time that's spent in milliseconds, or the time spent in percentage of time or milliseconds. It's just a great little tool to use. So definitely something to take a look at, because monitoring, not just Zen Server monitoring, but monitoring as a whole, is something that is definitely beneficial. We're at the end of our time pretty much, so I have a couple of pages here just talking about some non-PHP PHP performance rules. Often PHP is actually not the slow point of a website. It can actually be the front end, the HTML, and the layout that you have. So here's a couple of rules. I'm sure that we'll have these slides available somewhere on the net. And also be aware of your page size. There's often a direct relationship between those two. So these slides are here. We've got them in the webinar, so you can actually see it, and I'm sure the slides will. We do have, well, we don't really have time for questions, but that doesn't mean we can't answer them anyways. So the first one, we have some in the Q&A, and if you have some, you can put them into Twitter as well. But I'll be going through these very quickly. So how does Zen Server use resources compared to not using them? So I'm basically saying what's the performance impact of using some kind of monitoring. I believe it will be somewhere between 3 and 5% impact on performance. I have some data somewhere. I don't recall whether or not it was code tracing or monitoring or both. I think it was both, but it should be around 5% being your max. And when you look at the data that you actually get from monitoring and code tracing, it's cheaper to just simply buy another server and get a little bit of extra performance out of it that way, so you can actually have that data available to you. It's much the benefit is just staggering, particularly with code tracing coming out. It's really very cool. Next question: what benchmarks do you use suggest for core PHP performance? Basically, the question you're looking at here is for benchmarking code acceleration. I wish I had a link I could give you. A quick Google search should be able to provide something. Optimizer Plus, based off of my testing, has actually been the faster out of all the accelerators out there. Again, I don't have time to pull up the data, but you can go on Google and see if I'm pulling your leg or not. So just like with everything else, everything that I say here, go out and verify it. Don't just take my word for it. Again, use your brain. Is the PHP, I apologize if I answer that question quickly or insufficiently, because it's actually can be a complex question. Next question, is the PHP stack and Zen servers and platform faster than the normal PHP binaries? Yes, and that's actually because of the code acceleration that is built into it. If you're going to use one of the other ones, I believe the Optimizer Plus is faster as well. That can change based off of your individual results. So the PHP stack in Zen server, particularly in Zen server, is one that's going to be there than the normal ones. And installing it uses the native Debian or Ubuntu or Yum installer, so it's actually very easy to do. See, it's another one here. In a low-traffic application, high-volume data, does having the database server and web server running on the same machine affect the application's performance? Well, it will affect it because you're basically sharing resources, so you will have an effect. The question isn't whether or not it will affect it, but how large is the effect. And that's something that, unfortunately, I can't give you a direct answer on. It's something that you would need to look at your application and see what's your page load times. Use some of the monitoring and diagnostic tools to determine whether or not you need to add another database server, or whether or not kind of what you need to do. So that'd be a question that's very specific for an individual circumstance. So I can't give a direct answer on that, but there will always be an effect when you have everything running on the same machine. Next question, I think that I have two more to go. What setup do you recommend when having 5 front-end servers and an NFS, all PHP code? I say images I'm not as concerned about, because even so, I would say, if at all possible, drop NFS. It's a single point of failure, and it is not as fast as a local disk. If for images, it's not as big of a deal, because you might have 10, 20 images on a page. So that's 10 or 20 calls. PHP source code, if you're using any kind of a framework, you're guaranteed, I would say almost guaranteed, to have at least 100 files that need to be opened, if not 150 or maybe even 200. All those individual stat calls or fopen calls onto the NFS server for your PHP code is going to affect you. So your images, NFS, I prefer them being local on the machine, but you could probably get away with them being NFS. PHP code should be on the front-end web server and stored on a local disk, not on NFS. And then the last one here, I plan to switch from the PHP module to FastCGI as I recommended for the example in Light HTTP instead of Apache. We have a recommendation, or we don't have a recommendation either way. Apache is pretty fast, and Apache is not going to be your primary choke point for your performance in your application. It's most likely going to be your application logic itself. And so FastCGI, Apache is, there is a performance difference between the two, though it's not really all that great in terms of the actual difference, because of the differences in architecture. So I would, myself personally, I would have to have a very good reason to not run my PHP on Apache, because that's just simply the way it's worked for 15 years, and it does it pretty well. Now, static content like images, FastCGI all the way, if you have a need for high bandwidth. But for PHP, I have a tendency to favor on a Linux system. I have a tendency to favor Apache. On IIS, we have to use fast CGI because of the thread safety issue. We don't have to, but it's the way that Microsoft recommends to do it. And nobody knows Windows or IIS like Microsoft, so we go with what they say. So we have no specific recommendation. I personally use Apache when I can, most often. We have one more question, and I'll be 10 minutes over. So I apologize to everyone who's not able to stick around, or who did stick around. I think we had a couple of people who dropped off. That's understandable when we go over time like this, or when I go over time. Can grouping the maximum amount of source files into one file really improve speed? Yes, but that's what I would call a micro optimization as well. If you're using an opcode accelerator, I doubt that you would have that big of a difference. And one of the things, especially if you're not using an opcode accelerator, then it should actually be slower because you've got to compile one big massive file for each individual time. Basically, what I'm going to say is that I don't think it's going to be worth your time and effort to group them into one file. I don't have any specific data that I can base it off of, but that would be my gut reaction to say when doing that. In terms of the grouping. Okay, well that puts me 10 minutes over. Definitely I thank you for your time and for your patience as I kind of went over this again. Let me quickly bring up the original slide. If you have questions, you can contact us here. Do take a look at our Facebook page because we have information going there very often. Watch us on Twitter, both us and me. And the slides, yes, I can put them up on SlideShare, and I'll post them both on our Facebook page and on my Twitter, so that you can see them there. So you can get the slides as soon as I get them posted there. With that, I believe that I am done. Thank you for your time again, and I hope to see you again at another Zen webinar at some time in the near future. Have yourselves a good day.